Welcome to the 40th video in our series about Unix tools. In this video, I will show you how to write, compile, and run a simple C program. For most Unix systems today, everything should just work. However, for some systems, especially those machines with little storage or computing power, your system administrator may need to install some packages for you. Basically, the process from an application developer's point of view for a simple program is easy to understand. First, you create the source code, which consists of one or more .c files containing C language code, and in some cases, some .h header files. Second, you run the GCC compiler on each one of those .c files to generate a .o object file. Third, after you've created all the object files, you run the GCC compiler again to link the .o object files with libc to generate an executable. In this video, I'll show you how to do these steps. So, let's do it. We should make some place to work, CLand, and we'll go into that subdirectory, and then we're going to say, I don't want any weird stuff going on. I just want to create my Hello C program. Learning C is outside the scope of this video. But almost every program needs those, and you need a main function. In this case, we're not going to process the command line, so we'll use void, and then we're going to printf hello BUU, which will send a message to the standard out. And there it is. There's a simple C program ready to go. So we'll save that as Hello C. Great, we've created the source code. This is a simple one file program. We don't have any of our own header files, and we only have one C source file. So we've completed step one. Step two was to compile our C files into object files. And I said we'd use GCC for this. So we're going to say GCC compile only hello.c, and we want to output hello.o, which is the object file. On Windows, some people use obj, but on Unix, you use .o for an object file. Again, this may seem strange to you. We have no output at all. Did it work? Remember, the default for most Unix utilities is if everything's working, don't output anything. But we can do an ls-l, and we'll see, yes, we have hello.o. And so we've finished step two. We've created the object file. The third step is to link all the object files, and we only have one, to create the executable. And on Unix systems, the C compiler will automatically link in your C standard library, your libc, for you. So let's GCC, but this time no -c option. -c is when you just want to compile. But we don't want that. We want to do the link. So we specify our object files. We have only one, hello.o. And we specify the output file we would like to have, which is going to be hello. That's going to be the name of our application. Windows people, they're used to having an exe on there, but Unix people don't put an extension on an executable normally. So let's hit the button. Again, no message is output, but if we look, a file has been created. So this is our source file, hello C, which we compiled into an object file. And there's our object file, which we linked into an executable. And that's our executable file. And you'll notice that the system automatically added the right permission. It added execute for you. So how do we run this? Remember, you need to put a / in front, just like we did with the Python scripts and the shell scripts, to make sure it runs the program from this directory and not some other program with the same name somewhere else on the path. There we go. Hello BUU. It worked. And you might look at this and you say, well, that doesn't sound so hard. I can know it's a C file from the .c extension. I know it's an object file from the .o extension. But how do I know that's an application? I mean, it's executable, but maybe it's a shell script. Maybe it's a Python program. Normally we put .py or .sh, but you don't have to. So you might ask yourself, how do I know what that is? Most systems come with a special utility called file. And you say file, and then it will tell you what this is. And it tells you it's an ELF format, 64-bit Pi executable. A lot of this stuff is confusing, but at least you see the word executable and you see ELF. And those two things tell you that, number one, you're probably on a 64-bit system, and it said so. And you're running an executable. That's what that file would be if you run it. If we say hello.o, it will tell you that it's ELF and relocatable, but it did not say executable. It said relocatable. So you can't just run hello.o. It's not going to run. Number one, it doesn't have the permission, and number two, it's not really an executable. If we say file hello.c, it knows that's C source using ASCII text. Okay, we've got a lot of crud on the screen at this point. I haven't shown you how to clear the screen, and maybe you just hold the enter key like that, but it turns out there's a thing called CLS that you might want to try. And it says, I don't know CLS. And you say, daggone it, there's got to be something. Clear. Clear is the command you're looking for. And clear will clear the terminal and remove all that stuff. Okay. What did we do again? I forgot. Type in history and it'll tell you all the things you've done. And you have to sort of sort through there, but you can see here is where we created hello.c using the nano editor. Then we did a listing. Here is where we compiled the .c into the object. Here's where we linked the object into the executable. And here is where we ran the executable. And all that stuff's in the history. Is the history infinite? No, there's a limited size. Well, how do I store or keep the history that I want to keep? Use that redirection that we've already learned about. History, and then put it in some file like what I did. And then if you nano I've done something wrong here. Nano minus y none what I did text. Whew. Okay, there it is. If I do things correctly, it'll work. And you think, what are these numbers? These numbers are coming from the history command. Okay, those numbers are not from somewhere else. And wow, I've got too much stuff here. In fact, I've got 1,308 commands. That's more than I need. Couldn't we do better? Sure we could. You can use all the tools you know. A quick one, and we're pretty much out of time. We don't want to save that. But we will. We're almost out of time, but think about this. If you do history and you take the tail of history, what would you get? You can't do it because history is a command, but you can run it through the pipe and you can see, I've got the last few commands. So let's say I wanted the last 30 commands. Okay, that includes everything we need. And if we put that into the file, and we see there's only 30 lines, so we can jump to the end if we want to, and there it is. And you could remove the lines you don't care about, and you've got the history saved. We're out of time on this video. Please come back for the next one, and thank you for listening.